take 2 on this. Here we go. This is the standard sine function, so it's just going to have the standard table off of the unit circle. I showed you this in lecture, how I got this off of the unit circle. This graph is actually huge. This is a horizontal stretch, so it's 3 times as large. So instead of it going from 0 to 2 pi, it goes from 0 to 6 pi. And then on top of it, the book wants us to do 2 cycles. So I have to do a 6 pi and a 6 pi or get to 12 pi, okay? Hence me having to like find a different sheet of paper here. Okay, now let's go over how I just did these calculations. So the b value for this function is 1/3. Okay, the b value is 1/3. You have to put it in the formula. All right, so over here I'm calculating the period. All right, you have to put in the formula, so it's 2 pi divided by b is the formula. B is 1/3. You can plug that in. I wrote it the long way here, so it's 2 pi divided by 1/3. You have to make this multiplication and flip this, so it's 2 pi times 3, which is 6 pi. So that means the width of one cycle of this bottom guy is 6 pi. So it's going to do 1 cycle in 6 pi, and then the homework asks for 2 cycles, so then I have to do another 6, which puts me to 12. So that's why you can see this part here. All right, so that's calculating the period. Now, I taught you guys to calculate then what we would call the increment. And the increment is the jump from one point to the next point. Like how far do you have to jump to get to the next point? And the formula for that is the period over 4. So the period in this second case is 6 pi. We just calculated that. So I have to do 6 pi divided by 4, which reduces to 3 pi over 2. So the jump, I have to jump 3 pi over 2, jump 3 pi over 2, jump 3 pi over 2, jump 3 pi over 2. The jump to the next point is 3 pi over 2. So how you do that, right, is you start at 0 if there's no left-right shift, which there is not. We add 3 pi over 2 to 0, which gives me that. Then to get to the next point, I have to add 3 pi over 2, which gives me that. Then to get to the next point, I have to add 3 pi over 2. Now, I'm writing this real quick, but I had to actually get an LCD, right? Because this is over 2. So I had to convert this to 6 pi over 2, then add 6 pi over 2 plus 3 pi over 2, which is 9 pi over 2, right? So make sure you do an LCD when you add the increment. Alright, then I get 9 pi over 2, then I add the increment again, and I get 6 pi. Alright, so that is like the first. I was just sort of working on the more difficult one, because if I get this one right, this one's easier to fill in. Like this one's harder to draw relative to the other. So I was sort of filling this guy in first. If you want to draw this one first, it's fine. Okay, so then once I wrote, if you notice, I wrote all these values here. I made sure everybody, so I started with, I made the mark for 6 pi. And then I figured out what was halfway from here to here, like visually, and it looked like this about here. So that would have been half of 6 pi, which was 3 pi. And then I just did half of this distance. I just try to get it about the same. And then I wrote down what these were. Now, since you have to do 2 periods, I'm now adding the increment more than one table. So now I took 6 pi, I added the 3 pi over 2 to get this. I added the 3 pi over 2 to get this. I added the 3 pi over 2 to get this. I added the 3, right? So I know I have to go to 12, right? An hour later, we get over here. Okay. The good news here is that was the part that I believe was the most work. So it's downhill from here, okay? Downhill in a good way. All right, now you have to scale this the best you can. So try to think about how many units this might be. So what you want to think of is pi is about 3. So 3 times 3 over 2. So this is 9 over 2. This is about 4.5 units. This is about 4.5 units. So if this is about 4.5 units, what would a 1, if you're using this as 4.5, what would a 1 look like? It would probably be around that, right? You'd fit about 4.5 of that. Okay, again, this isn't about perfection. It's just that you were thoughtful when you drew your graph. By the way, you could go left, you could go left, you could go right, you can go left and right. I just chose to the right. Okay. Yes, you might find it easier to go 6 pi to the right and 6 pi to the left. You guys don't have to do it the way I'm doing it. All right, now I'm going to draw this guy first. Since I got all this down. So 0, I'm at 0. Let me just, my brain wants this a little bit more accurate. Alright, 3 pi over 2, we're at 1, so we go up, then we go to the middle, right, I'm just following this here, then we go to -1, alright, then we go back to the middle. Alright, let me just draw the first cycle here. I'm going to feel like this is a major accomplishment. Okay. Right, this guy's long, so this guy's really getting stretched. This guy's getting stretched out. I don't know what you guys are thinking, but when I'm thinking long hair stretched out, I'm thinking, man, I'd like a vacation like that, and I think we got one coming up. Okay. Alright, here we go. Now I'm going to repeat the pattern, right? So I'm at 0, then I go up 1, down 1, back to 0. Okay, I'm going to draw it again. Okay, so this was one cycle. This is one cycle of this guy. I'm about to draw another cycle. Again, if it's not a Picasso, the Picasso police are not going to arrive at your house. Just, you know, just give it a good effort. A lot of life is just about showing up. It's not about perfection. You know, it's just about showing up, really. That's probably a good percentage of it. Alright. It's just sort of, you figure it out as you go along. Alright, now I want to put arrows on this because this never stops oscillating on both sides. Okay, so notice I'm putting arrows on both sides because this goes on and on until infinity. Infinity. But we are done. We're done with, let me be careful how I phrase that. We are done with x over 3. So let me label that. G of x equals to sine x over 3. Alright, that is your green function. Okay, now the red function. Oh, I'm going to make it red. Let me see. Now we have to draw 2 of these. Now, notice the increments are different on this graph. So I've got to now figure out, because they want it on the same graph. Okay, so I did the more difficult one. So let's sort of match this up, like where would things go? Right, this is 1.5 pi. So this is a pi over, this is 1.5 pi. So we have to figure out where 2 pi would fit on here. So let me, this is 1.5. 3 over 2 is 1.5 pi. So how you want to think about this is if this is like 1.5 pies, then if I cut this 3. I've made like pi over 2 pi. Basically what I'm doing is okay, let me say this better, because the brain is, part of this is doing it and part of this is teaching it. Notice here that the increments are pi over 2 for this, right? So my brain is trying to figure out how to put the pi over 2's into this graph. So if this is 1.5, that means that 3 halves would fall into here. So 3, this would mean there's 3 pi over 2's in here. So I was thinking, okay, well, let me fit 3 of them in here. And to fit 3 of them in here, I have to figure out, well, what about would make a third? So I had to visually sort of figure out what a third looks like. So I've now got it. So I know that 3 cuts I can put, so like for instance, if I add pi, so my cuts now are by pi over 2. I'm not doing 3 pi over 2 for the increment now. I'm doing the increment of pi over 2. So for me to get to 3 pi over 2, I need 3 of these increments in there. So I did 3. So my jumps now, there's 3 little jumps to each big jump, right? So if I add pi over 2 to this, that's 4 pi over 2, which is 2 pi. If I add pi over 2 to this, that's 5 pi over 2. If I add pi over 2 to this, it's 3 pi, right? So think of it, this guy is 3 times bigger than this guy, so 3 increments would fit where 1 is. If this is 3 times larger, then 3 little guys make 3 little increments make 1 big increment. Okay, I hope you understand what I'm saying. Here we go. Let's start with the first one. So 0, 0. Then at pi over 2, we're at 1. Then at pi, we're at 0. Then at 3 pi over 2, we're at negative 1. And then at 2 pi, we're at 0. Now let me draw that. That's one cycle. That feels so funny after we've just drawn this mammoth python here. All right, now we have to repeat that. We have to repeat that. You know what? I didn't add these little numbers in here for you. Let me put them in. So if I add pi over 2 to this is 7 pi over 2. If I add pi over 2, that's 4 pi. Did I put 3? I didn't put 3. Hold on. Hold my horses. 1, 2, 3. Oh, I have, okay. 4 pi. Pi over 2 is 8 pi. 8 over 2 is 4. Yep, okay. All right, now we're going to draw it again. So now you're at 0, you're back at 0. You're going to scan through these values again. So you're going to go back up to 1. You're going to go to 0. You're going to go to negative 1. And then back to 0. Right? Because if it does 1 cycle in 2 pi, it's going to do 2 cycles. You add another 2 pi and 4 pi. That's where it finishes. And I'm just going to put a little arrows on here, because remember, this goes on and on. So this is this is the original. In my opinion, it's easier to draw the stretched out one first, but however you do it is fine, because really at the end of the day, you know how you understand it best. You might understand it best drawing this first and then drawing the other one. Okay, gang, that's it. I hope this was helpful, and it's certainly like a creative way to sort of start understanding all the rules. So I could fit, this one is 3 times longer than one of these, right? So whereas 6 pi is one of those, 2 pi is one of these. So it's a third. It's 1/3 of this guy's 1/3 of this guy. Okay, so it's crazy ratio. It just looks funny compared to itself. All right, gang, that's it on this. Catch you.